Welcome back everybody, and here is the first part of making a VEX robot, especially for the pushback season. Now I know this is quite late in the season, we're almost at the new year, but it's a good tutorial for those who haven't built a robot and would like a starting point. Now all of my designs will be linked in the description below, and this is what we're basing it on. Now this is just the skeleton of a basketbot, and yes, we will be CADing a basketbot today. You might be asking why not an S-bot, why not a rig one. Well, this is quite simple to understand, simple to CAD, and it's good for a first time team. Now when this was a meta is when my team, 14008 Hyper, had built theirs, and we are still running it, it's still working fine, we're still out competing the rest of the competition. And you can search our team up on YouTube by searching 14008 Hyper, or click on the link down in the description below. So this is what we're basing it on. Now to hide the skeleton of the intake, and this is the skeleton of our drivetrain. Now it's a 6-motor drivetrain. It's going to be as thin as possible in between these two C channels, and that is because it's going to be the easiest to build around it if it's not too chunky. Now some teams do have it much farther apart, that's fine, but our team does not like doing that. For this design you will have to cut your gears in half. Now we are using high strength gears, so as you can see in this model here, it will just be a straight high strength gear and it's just cut in half. To do this, what we used is a bandsaw, and we just cut straight through it. Obviously not through the metal, and then we just finish the metal off with a hacksaw. You could just do it all with a hacksaw, but you have to be really good at it and have a really straight cut. We got 2 pieces out of every gear, which is good. If you aren't good at cutting, then you might get one good piece, as you have to have this surface completely flat. Now going back to our design, we're going to be using this 2 wide C channel for most of our structures. Now this is a design of my own creation, and it is a parametric design, which means if I open up my parameters here, I can change the length, say there, and it's obviously, it will be double the value that you put in. That's because one of these blocks is going to be too long, so if I want a 15 wide, I'll have to click 15, sorry, if I want a 30 wide, I would want to press 15. So once this is done, I'm going to press OK. Now this is going to be the base of our model. We're going to save it. We're going to go to a new design, and we're going to import our new 15 wide, so 30 long C channel, and we're going to put this face facing the right. So we're going to rotate this first of all 90 degrees. So when we're facing the front, we're going to be looking at the front of our chassis. And now we're going to rotate this one 90 degrees. Now I'm doing this so it's more real. Like it will represent it in real life using this cube. So if I want to look at the top of my robot, all I have to do is press top, and it will let me look at the top of my robot. So this will be the front, this will be the right, this will be the left. Now I'm going to import another one. I won't be putting all the spacing in because that's a personal choice. If you want, you can define your spacing any way you like, but first show your team what you're doing. Sorry, this is -90, which is not what I want. Get rid of this negative. We're going to put 180 again. Now for me, I'm just going to eyeball it because this is not very necessary for you guys. obviously you want to know what the distance is. Now in Fusion, if you don't know how to do that, all you're going to go into this inspect tab, press inspect. Let me just measure, but I will show you that you can just click this point here, click this point here, and it will give you a measurement if you just press this measure tool right up here. Now once you have this in, we're trying to figure out our spacing for our gears. Now I'm just going to use this as a example. Here the gears are, the idler gear is going to be located on the wheels themselves, and that will be a 48 tooth gear, and a 36 tooth gear will be directly connected by a shaft to the full motor here on the bottom row of holes on the C-channel. Now this is going to have to be something you're going to play with, and I'll meet you back when I've finished. Okay, so now that we have put all of our wheels and gears in, as again, just have to match them up. It's quite simple, and I'm sure you'll figure out. I've just got and put the bearing box in as well. Now you don't have to do this on a CAD, but it's very good too, because your builder will absolutely love some extra help. Now I know that because my builder has asked me many times to put everything on the CAD. But in reality, this CAD is just meant to show where you're going to put everything. Now you're going to put a high shunt axle on the bottom here. I've already done that, and I've kind of hidden it so far. So I'm just going to put that back in. It's quite simple. Just place it where you think is going to look good, and just press this face here, and all you have to do is extrude out. I just clicked the sketch button when I meant to press extrude, click the surface, and all you can do is just extrude and cut the body. It's quite simple, and you will figure it out. So this is the basics of the chassis, and I will get back to you in the next video of how to add the motors and start building the intake.